Hi, this is David Daniel, presenting for class Data 625, Data Visualization. This is the Unit 6 presentation for network graphs, and I'm doing a network security analysis. We'll start by analyzing the first data set, which is the network 02 data set. And this is a fairly robust data set that contains a number of names and names, which we're using as nodes here, and connections between these nodes, which are edges. You can see that the network of users are distributed and connected pretty widely, in that if any one of these nodes were to go down, there still would be sufficient connections surrounding them for the nodes to communicate. Specifically, the nodes in green are the ones that are most connected, or most interconnected rather. And these are the most critical nodes where the most information will be passing through. So in the event of any single node going down, really the most critical are the ones in green. That being said, there are a number of ways to get around these critical nodes because there are sufficient kind of collateral edges surrounding them. If we look at network 3 at this data set, we see a very different architecture to this network, where we have this one bridge between Nebula and Starhawk, where almost all the communication passes through. So in the event of, let's say, a malware infection, this would be a lot safer, right? Because you can kind of just cut off any communication here, and let's say if this area was infected, this area would be spared. But also, if there is a technical difficulty where there's a technical difficulty within this edge, it would be difficult for anyone to communicate from this side to the other side. So that being said, there are benefits to each of these network setups. With network 2, being interconnected means that in the event of a malfunction, you'll still have communication between many of the nodes. However, in the event of a malware attack, it becomes far more contagious. When we look at network 3, in the event of a malfunction, it may be a lot more difficult to effectively communicate from one side to the other. But in the event of a malware attack, it would be a lot easier to contain that infection, right? If one of these peripheral nodes is infected, or even if one of these critical nodes is infected, it'd be easy to kind of cut that off. Thank you.